Hello everyone. Welcome to the March Fundamentals. Tonight, our presenter, Drew Carhart, is sharing his enthusiasm for Victorian-era books with us. If you think about it, we do share common experiences with past astronomers when we look through our own telescopes. We marvel at Jupiter or star clusters, much as Galileo did, and seeing them as if for the first time with our own eyes. Tonight, we will learn that the experiences of the people who wrote these classic books can still be relevant to us today. And now, let's welcome Drew.
Thanks. Let's see if the machine works first. Look, I usually don't like presenting with the laptop in front of me, but as I was saying to Andrew earlier, there's numbers and things in this talk that I don't want to get wrong. So, no, that's not it, Tony. Keep on trying. So, we're going to make do with the laptop thing, and then I don't have to turn my head as much. So, talking about Victorian, what does Victorian mean? Well, this is the Queen of England from the late 19th century, Queen Victoria, and so the Victorian era was while she was queen, which is these years, the 1837 to 1901. So it's roughly the second half of the 19th century where I'm going to be bringing us to in history and talking about things. I'm going to step outside of that period a couple times on either end, but I'll note to you when I do that. So as a really brief prelude thing to this, I just, to get us in mindset of what life was like then, here's Chicago in 1860, mud streets, horses, wooden boardwalks. There's Edison not patenting the first electric light bulb till 1880. Here's Chicago in 1893. Pretty much still the same mud streets and horses and things. Ford didn't patent the Model T until 1908, and just to keep other things else in mind, it's estimated that only about 1% of American homes had indoor plumbing in 1900, so a different era than we're in now. If you come to Naperville here, this is Naperville in the second half of the 1800s, with mud streets and horses and board sidewalks and cash paid for hides. So a little bit different than today. A brief explanation of why I'm even talking about what I'm talking about tonight, as witnessed by this being the 50th anniversary year for the formation of our club. I have been pretty much always interested in astronomy and stargazing. I also have pretty much always enjoyed antiques, which I like just seeing because it's a connection to me, not just with the people who used them, but especially the people who made them. So I like restoring antiques, and I get a lot of pleasure from them. The book thing began with my mother giving me an old astronomy book out of her collection some time ago, and in reading, and this was just a popular astronomy book, meant for the general public, to get people interested in astronomy and stargazing. And in reading it, it made me realize how much of a connection I have as an amateur astronomer today to people in the past who had the same hobby. So, being somewhat of an inveterate collector, I started collecting Victorian-era astronomy books, and unfortunately, I have quite a few of them now. So this is what tonight's talk is going to be based on, is things derived out of these books. And most of them, again, I've concentrated. I could go back earlier than that period or collect a lot of 20th century books, but I've kind of just stuck in my collecting with more the Victorian era things because I only have so much space in my house. And for some reason or other, the era resonates with me. So, in my presentation tonight, I'm going to divide it kind of into two groups. First, I want to talk to you a little bit about this state of astronomy as a science in this era, because there was a science. There were people approaching astronomy in a scientific manner. Referring to them as professionals is tough because before this era, before the Victorian era, everybody who was an astronomer really wasn't a professional astronomer. They weren't getting paid by somebody to do astronomy for the most part. They were mostly people who could afford to do astronomy. They could afford the equipment. They could afford the time to do it. By the time you get into the Victorian era, you are getting universities especially and things that are starting to support research in astronomy, so we're getting real professional astronomers. Anyway, so we'll look at the science first, and then we'll look at the amateur side of it, the stargazing side of it, and see how different or similar the hobby was back then from what it is now. The Victorian era came on the coattails. It followed what was called the Age of Enlightenment. And the Age of Enlightenment is this mostly 18th century period where people in the Western world started realizing that knowledge was a thing you can gain, especially through science, that investigation led to discovery, and there were real truths about things that somebody could measure here and somebody could measure there and come out with the same measurement. So by the 19th century, by this Victorian era, there was actually a lot of respect for scientific understanding, and there was a lot of popular interest in scientific discovery and understanding about things. It was common knowledge. You could ask people on the street. There was common knowledge that the sun is a star, just like the other stars in the sky. This wasn't a generally debated thing. It was pretty common knowledge that there were millions of stars. This text here is out of one of my books. You'll note a lot of numbers in it that, for instance, Otto Struve had estimated that in William Herschel's, now it says 20-foot reflector, that was 20 foot long, it wasn't 20 foot wide. Anyway, you could view more than 20 million stars. So we're starting to realize there's a lot of stars out there, more than just what we can see with the unaided eye in the sky. Herschel gives the number of 18 million stars in the Milky Way. He actually tried to calculate that by saying, I can see so many stars in my eyepiece field looking here, and my eyepiece field is looking at this percentage of the Milky Way, therefore that there must be this many stars. So anyway, they knew there were countless millions of other stars out there. Then there's this concept of the plurality of worlds, and this actually, well, this is a book from that era. I'm going to flip back a little bit earlier. This is a book that was written in the late 1600s. Fontenelle wrote this book called A Conversation on the Plurality of Worlds, and it was actually a popular book in, believe it or not, it was published in 1686. This is the I have to look at the number, 1774 copy of it in English translation. You can still buy this book in print today. So it was a kind of a sea change introduction to the concept that our sun is a star and it has planets going around it. And we see all these other stars out there, so they probably have planets going around them too. So there's countless number of stars, there must be countless number of planets out there. So this actually became a popular concept. You could have asked somebody who had had some education or another about science, space, natural history, or whatever in the 1800s about the plurality of worlds, and they would have said, yes, that's a thing. There's going to be planets all over the place. So this is not a new concept from today. It was kind of a foundational thing back then. So then we get some really great discoveries. This is a monumental thing. The two gentlemen in the pictures are Gustav Kirchhoff and Robert Bunsen, and together they demonstrated that the spectrum of light can tell you what elements are present in the thing that's emitting the light. So they showed that in the laboratory on Earth, and then almost immediately, the paper was the translation of Kirchhoff's paper from just a couple years after they first published their thing on chemical spectra, where he applied it to the sun. And he said, look, we can see all these lines in the sun's spectrum, and we can line them up with elements we see here on Earth. Therefore, I'm showing you that the sun is made of elements that we have here on Earth. There's another really big sea change thing to say that this cosmos, that stuff out there, is the same as us rather than somehow mysteriously different. So that's a big evolution in the science of astronomy to not only be able to say we can see the stars. People had been measuring the stars. Chris has talked about Chinese astronomy going back thousands of years, and measuring where the stars are in the sky and figuring out positions of things is a big thing. But this is the first time we're taking apart the light and learning all about what the stars are made out of. So big step. All of a sudden we can almost reach out and touch the stars. So yeah, here's stellar spectra with the sun at the top and a few other the first really bright stars that they could manage to get spectra of, showing, hey, look, we know what it's made of. So it's a big change. Now, there's still a lot of things that we don't understand at this period. Telescopes are showing all of these fuzzy things up in the sky. They get the generic name of nebulae because it's from the Latin word for mist or cloud. And we're seeing cloudy things, and nobody has a clue as to what they are, really. There's no evidence in the light coming from them of exactly what they are. So there's a lot of theories. One of the fairly common ones is that they might be solar systems that are forming. So, because a lot of them tend to have a bright spot in the middle of them and fuzzy stuff around, and Laplace had made this theory that star systems form by condensation of clouds of gas and dust, and so other people are saying maybe that's what we're seeing here. Now we know, of course, that nebulae are all sorts of different things. Some of them are where stars are forming, some of them where stars have died, some of them are whole other galaxies with billions of stars in them out there. We know those things now, but back then it's like it's a fuzzy thing in a telescope. So, okay, so here's the big thing: is stars. I like this picture of sidewalk astronomy from the Victorian-era from London. I think the sign says, it says John Dobson. It says, "Come and see the moon." So people were doing that before John Dobson. But anyway, stars, all of a sudden we know their chemical composition. They have hydrogen in them, they have carbon in them, they have iron in them and things. But what their energy source is, science hasn't a clue. It was a real big mystery. And so here we have Herschel in 1833 in his seminal book, kind of gathering everything known about astronomy together on it. This is John Herschel, son of William Herschel. And he has no clue, and he admits he has no clue. Combustion seems like an obvious thing because here on Earth, things that are hot are on fire generally. But it doesn't exactly make sense. We can't figure out how something could burn for so long and so steadily, like they had known the sun had been burning for a long time. Could it be friction? I mean, is the sun moving through the ether and just getting friction on it from moving along? Who knows? Could it be electricity? You'll notice electricity mentioned in there. Electric discharge, I think is the way he terms it. There were lots of theories, but none of them clicked as being, well, that's obviously true. If we go a little forward, we've got people asking this even. And so the theory is that the sun is a solid body, like a planet, like the Earth, and its atmosphere is on fire. So, because all we see is this sheath of what would be like clouds, and it's like it's on fire. So the theory is if there's the tops of the clouds are on fire, but there's thick clouds underneath, that might insulate the planet from that fire up there, and it might be habitable down on the planet. It doesn't seem very logical to us today, but people are like, I don't know. So moving along in more theories, we have Mayer, who in the 1840s actually did the calculation of combustion and how much fuel it takes to make to release a certain amount of heat. And he demonstrated that the sun just couldn't work that way, because they had known it had been burning for thousands of years, probably tens or hundreds of thousands of years at least. And there was anything that could just sit and burn like that without running out of fuel. So he could demonstrate that mathematically. But he showed that much more heat could be generated by the sun being steadily bombarded with asteroids, meteoroids, meteorites, planetesimals, whatever falling into it. And he did the math on that. He said, look, I can generate that enough heat if we just have this steady stream of things crashing at high speed into it. So that was his theory. You get Hermann von Helmholtz, who disagrees with him a year or two later, and he calculates, he's a mathematician, and he calculates that it was more likely in his point of view that you could generate that heat by compression, by the sun slowly crushing itself, because when you compress something, it heats up. So he votes for heating by compression. So there's a lot of debate about this, and nobody coming up with the theory that everybody else says, although Helmholtz's theory was popular for the next 50 years or more, actually, and referred to a lot by other people, this compression thing. But we actually have to jump out of the Victorian era and get all the way up to 1926, and Arthur Eddington, whose paper and then book in 1926 finally laid out what we know today to be the truth, that nuclear fusion is going on inside the sun, and that's the source of the heat and radiant energy output that we see from it. Before that, even in the 1800s, some people had posited that the sun was a ball of gas instead of a solid body with an atmosphere around it. But it really wouldn't be until Eddington's paper that the correct answer came out. But again, that's well beyond 1901 and the end of the Victorian era. So we've got science knowing quite a bit, but not everything yet, obviously. If we switch over to the question of distances out in space, this is Friedrich Wilhelm Bessel, and in 1838 he was the first person to reasonably accurately determine the distance to a star beyond our solar system using parallax. So he measured the distance to 61 Cygni, the star, it being a little over 10 light years away. His number was not terribly far off from what we think today is the accurate measurement to that. That measurement, that putting a number on there, really demonstrated the immensity of the cosmos. A number of people had tried a number of stars. That was the first successful one to come up with what looked like an accurate figure. And what it demonstrated was that there's very few stars that are close enough to measure this way, and even the closest one that they could find was 10 light years away, which is a long ways. So all of a sudden, I wonder how big the universe is thing got, well, it's pretty big, because 10 light years is a long ways away. So the distances to the nebulae, and even to the farther stars, the non-local stars within our own galaxy, those distances remained out of reach of measurement until well into the 20th century. So, but again, this is a foothold here of saying you no longer can guess that that's 1,000 miles away or whatever like that, because we've got this figure that is mathematically good, that things are really big out there. So, flipping into the more interesting part here, talking about the stargazing part, the thing that we do. Oh, and I should say, if anybody has anything that they want to, should have done that. A question you have, if you think I could remotely answer it.
Actually, I just have a question on the distances. They weren't using light years as a measurement though back then, were they?
No. I believe he was probably actually calculating miles and in scientific notation. I'd have to go back and look at the paper. But yeah, so that hadn't been adopted, I don't believe. I think it was another 20th century thing to say, hey, guys, all of these distances we're talking about. Actually, he might have been working in astronomical units. because he was using Earth baseline for the bottom of his triangle for doing the parallax measurement. So I wouldn't be surprised if that's true. Steve?
So that gentleman, Stuvey, that you mentioned earlier, was he an early relative of the Stuvey who ran?
The Struve, yeah. That's a dynasty. There were like 3 big astronomers in that family going through the years up to Otto. So
Right.
yeah, I believe they're all related, if I'm remembering that correctly. So anything else? See, Marty.
Yeah, when did they start using parallax to measure the stars that were close enough to use that method?
Well, like I said, that was a parallax measurement that
Okay, all right.
Bessel used. That is parallax. So that's how he came up with what we would now call 10 light years away. So that was based on the Earth's orbit, observing in March and observing in October, or whenever it was, and looking for motion against the background stars. So that's what he was doing. Okay, so Victorian stargazing. What was I going to start with that? Okay. Again, going back to looking at the books, it's actually quite amazing to me how many books I can find that were written during the Victorian era for the popular audience in astronomy, for both the science and for the stargazing ends of things. Some of these, like Flammarion and Guillemin, who else in here? Some of these were written, there's both French authors. There's several French authors that ended up getting eventually translated into English. But there's just a lot of them, and it kind of indicates, again, the popularity of this as a subject for consumption by the general public, which is interesting. Again, I don't know if you picture the people in those early pictures I showed of Chicago walking on the boardwalk by the muddy street with the horses going by, talking about what the energy the source of the sun is and things, but it was popular back then. So Scientific American goes back into that era, and there were a lot of articles in Scientific American trying to share some recent discoveries or whatever. There wasn't a skying telescope, but again, it was a popular hobby. So as I was saying, just like today, I've got the 2 books here. People were interested in both the science and in stargazing. And like today, too, I think it was considered to be a very modern hobby, a very modern interest, because there's all these discoveries being made. So, and there's all this new equipment being built, too. There's always stories of the newer, bigger telescopes going in somewhere around the world, and that was followed with interest. The World's Fair, the World Columbian Exposition in 1893 in Chicago, had the Yerkes Observatory telescope on display in it. Before it was installed up in Wisconsin, it was at the World's Fair in the industrial building, I think. So a picture of this huge telescope on its mount, set up at the fair. The telescope had to be kept horizontal because it was way longer and taller than the building was tall. But again, very popular thing. And again, a real modern thing. It was state of the art to know what's going on in the astronomy world. So again, like a lot of people would think it is today. So, oops, forward. There we go. So, looking into these books, what can we learn about what it was like to be an amateur astronomer back then? So, I like the Astronomy with an Opera Glass. It's actually it's a very fun read book. It's just like Astronomy with Binoculars today, which I have a book on written 15 years ago or whatever. But in this case, it's the Opera Glass. So, and the Romance of Astronomy. You got to love a title like that. So let's think about telescopes. I mean, people had telescopes, and they were popular. But I think a lot like, you could compare it very much to today also, they could be relatively expensive. So if you were really into the hobby, to get a usable small telescope would cost, more than a loaf of bread by far. Or you could be really rich and get a really big telescope or a really much fancier telescope. But looking at the telescopes more specifically, for instance, the achromatic lens, which there's one in this diagram of the telescope there on the left, that was invented in the 1750s, the achromatic lens, the color-corrected lens. So by this era, any good astronomical telescope certainly had or refractor, I should say, would have a achromatic lens in it. There's no question about that. You're doing a lot. You may not be up to quite teleview standards, but you're doing a lot better than Galileo had by a long ways. If we look at reflecting telescopes, which are also popular, did I just switch? There we go. So these two gentlemen in the 1850s, this is Foucault, or Foucault, as most amateur telescope makers would call him, up in the above, and below him is Carl August von Steinheil. And together, these two gentlemen invented a process for depositing a silver coating on a first surface mirror, a first surface glass mirror, I should say. Up to that point, all reflecting telescopes had been made with metal mirrors, probably most often an alloy, which was generally called speculum, which was copper and silver and tin and something else or other. It would be poured and then ground like glass into the shape of your primary mirror, which might have been spherical or might have been parabolic. By Foucault's time, it was parabolic. He invented that test that John's done a lot of times. Anyway, so you would grind this metal that way, and then you would polish the metal just like you would polish a silver tray or a piece of flatware or whatever to make it a nice shiny surface. The problem with that, especially compared to glass, that shiny surface wasn't quite as reflective as our aluminized or silvered glass mirrors are, but it would also start to tarnish almost immediately. So with your telescope, especially if it was outside or out at an observatory or whatever, depending on your climate, that mirror is going to tarnish more and more and get less and less reflective in a relatively short time, within a year or something or other, very well, depending on where you are, of course. It might be tarnished enough that it needs to be repolished. And that doesn't mean, like we do now, of taking the silver off and putting a new layer on. That means totally refiguring that piece of metal with a new surface on it to get rid of the tarnish, because you can't just wipe off the tarnish and have it stay in the nice same shape. You have to wipe off the tarnish and refigure. So a very tedious way to run a reflecting telescope. With the glass method, you have your nice piece of glass, which you grind to shape. When the silver you put on it tarnishes, you wash that silver off, put a new layer on, and you're ready to go again. So much more practical for making reflecting telescopes. So these two guys get the credit for doing that. Not that metal mirrors weren't still used for quite a while after that. I'll get into that in a minute. Okay, so what sort of telescopes did amateurs actually use? If you were back in 1880, what kind of telescope would you be getting? We get some interesting clues. You might be familiar with this series of books, the Webb's Deep Sky Observer's Handbooks. They're basically catalogs of things you can look at in a telescope. So they're just great lists by constellation of all of the objects they're split into the different types of objects between the books, but basically all of them in a certain constellation with some basic information about them, and besides their location, their coordinates, some description of what you're going to see or what you should be looking for. How bright is it? How big is it? What did so-and-so see when they looked at it and somebody else see when they looked at it? This series has its origins back in the 1860s with the Reverend Thomas William Webb, who wrote these two manuals called the Celestial Handbooks, or Celestial Objects, for common telescopes. And they are just that. They are two books with catalog lists like that in them. And he also has his codes for telling you about, he puts in some nice little florid phrases every once in a while about so-and-so said it looks like, reminds me of this and that, whatever, but he uses a lot of codes that are kind of reminiscent of what Robert Burnham used in the Burnham Celestial Handbooks, for those of you who are familiar with that. So you have to like figure out what the code means for in his descriptions about things. But one of the things he includes a lot of is the observations of other observers or himself of the given object, and he'll list what telescope they were using. So you can read through these catalogs and see all these different telescopes listed that people were actually using in the 1860s, and these were actually revised. I think my version is 1880 something, 1890 something. I can't read it on here. 1894. So these did have things added to them over the years too in the subsequent publications of them. But again, they're the foundations for the Webb Society handbooks. So looking at things he lists, let's see. So he refers to, for instance, his 9 1/3 inch spec, SPEC, which means a Newtonian reflector with a speculum mirror, a speculum metal mirror of 9 1/3 inches in diameter. So he's got it's not a common size. It's not one of the standard, the 6, 8, 10, 12 and a half sets that we use nowadays. Because this is a cast metal mirror that was probably just made for his telescope and no other telescope or whatever. He lists reflectors with both glass and metal mirrors. He'll note whether it was a glass mirror or a metal mirror. And the sizes on reflectors go from around 3 inches, I remember reading in there, all the way up to Lord Rosse's 6-foot telescope. He'll say, Lord Rosse sees this and that in his telescope, describing a certain thing. So he covers a lot of bases as far as including people's observations in his manual. If we go to refracting telescopes, he mentioned again of his own things. He mentions his, quote, 5.5 inch object glass by Alvin Clark, which means it's a 5.5 inch achromatic refractor with the lens by Alvin Clark. The famous Clark and Sons made a lot of big telescopes like the one up at Yerkes and things. He notes refractors from around 2.5 inches in size up to the largest ones in professional observatories, so up to 20 and 26 inch refractors. He notes the observations of in his book. So it covers a wide range of different telescopes. What did I put in here for notes? Oh, for mounts, there's quite a bit of variation too. He's not as specific about that, so it takes a little bit of extra research to see what so-and-so's telescope was on. It wasn't uncommon then for both some refractors and reflectors to be on altazimuth mounts. We tend to think of the Dobsonian mount that goes back and forth and up and down, that's John Dobson. Well, if you look at the Herschel's telescopes, they basically were like Dobsonian. Their reflectors were basically like Dobsonians. They went back and forth and up and down. They tended to have a support rod that would hold the front of them at a given angle or another, but they were basically altazimuth telescopes. But there were also a lot of equatorially mounted telescopes, especially in the refractors and in smaller reflectors. Really fancy ones in that era would have clock drives on the equatorial mounts, and of course this is a weight-driven clock drive with a real clock. That's where the word comes from. There's a clock mechanism in there ticking away, and it's weight-driven to turn the telescope at 1 revolution per day to turn them out. So again, there's a real variety here of both kinds of telescopes and mountings. And so I picture a star party where a group of amateur stargazers like us would get together in 1875 or something. You'd probably see as much variety in telescopes as you do at the star party today, because especially since there wasn't a Celestron or a Meade that was making everybody's telescopes. They tended to be more local telescope makers were making things. So there'd be a lot of variety. One thing I think might be a little bit different about that era is I get the impression that more serious stargazers tended to have their telescope mounted in their own yard in a small observatory or something, probably because more people lived in areas where you could stargaze from than we tend to nowadays. And so that, and also because things might tend to be a little heavier equipment-wise than some of the things that are built today. That gets me to a footnote. One thing that I find interesting, some of you know I work in light pollution stuff a lot, but this book, the author, this was a French book translated to English, the author Mendier Guillemine, this book was written in French in 1867. He gives, in writing the first notation I've ever found talking about light pollution, because he's talking about how many stars you can see in the sky. And he notes, let's see if I can find the quote, get it close. I'm not sure if the translation is really good, but he just notes that the number of stars that can be seen near centers of population with the lighting of their houses and streets is notably reduced. So he's saying back in 1867 that you want to get away from the houses and streets. And remember, 1867, you're talking candles and oil lamps. And so he found candles and oil lamps annoying to stargazing. And I don't know what he would say today if he could look at what our sky is like here in Chicagoland, but he would probably be very much disappointed. So, well, we're getting close to the end here. So summarizing, between then, the Victorian era, and today, well, the star chart is still a star chart. I don't look at these star charts and say, wow, what constellations are those? I mean, it's the same star. You could use this tonight. It would work fine, except it's the autumn chart. I'm sorry. It's turned to the wrong page. Should have turned it to the spring page. There's still a lot of pleasure in learning your way around the sky. That hasn't changed between then and now. I still wholeheartedly recommend people enjoy learning their way around the sky a little bit, and a lot of the books were very much leaned toward that, especially the ones for beginners, was learn your way around the sky. There's still the same universe up there, full of beauty and wonder that there was back then. We may know some more scientific facts about the stuff we're looking at than people did in the Victorian era, but that doesn't change the amount of awe we can get from looking out at the cosmos. I mean, I think you can feel a direct, if you look at the moon and see the craters on the moon, you can feel a direct tie to somebody looking through a telescope 100 or 150 years ago and looking at the moon and saying, wow. So that hasn't changed much at all. People back then were amazed by what the technology of their time revealed, what you could see. The cutting edge of things. This is cutting edge from, here's Jupiter in 1889. How amazing, much detail you could see on it. The moon, and this is before that. These drawings of what people saw. This isn't photograph, this is drawing of what they saw in craters on the moon. The solar prominences are the date there. There's a date here somewhere. Oh, 1872. So shouldn't get off the subject too much, but the person who drew that was hired as an artist by Harvard to do astronomical things He's a very interesting character. He did a lot of different things in his life, including importing gypsy moths to the United States to try to start the silk industry. But that's a side shoot of. Anyway, this is very comparable to opening up Sky and Telescope and seeing the amazing picture, or some of you going out and taking the amazing picture of things. It's like, wow, look at what we can see of the universe with our cutting-edge technology. Rick?
In 1872, how is he seeing prominences?
Yeah, that's a good question.
He's old.
That's something
I
to.
mean, that's impressive if he's getting that kind of detail
Yeah,
during the
that's
totality.
that's something for you to research. See, I've gotten you interested. They had some sort of setup at Harvard where he could do that, and I'm not sure what it was because I haven't dug into it. So. But he was hired as an artist for being able to depict things so amazingly well. That's great.
So I assume a lot of these, especially these types of level of quality drawings, had to be hired artists. I can't imagine the
Yeah,
person
well,
who actually owned the telescope had the.
I have a lot of books with a lot cruder drawings in them.
Oh.
And some of them just, I could go, oh, well, I'll show you in a minute. I think I've got some coming up. Actually, I do. We can go ahead. There were, what this slide was, I was going to say here was that there were a lot of unsolved mysteries. There were things people were seeing in telescopes that was like, what the dickens is that? And, but, you know, the reality is that's just like today. There's a lot of unsolved mysteries today that we don't know the answers to, and that maybe in 100 years somebody's going to be looking back, yes, back in 2023, they thought there was dark matter, you know. So, you know, who knows? But, yeah, so the drawings, you can figure out what some of these are. That's Andromeda up there. But some of the things that were drawn at, Lord Rossi in Ireland didn't do any observing with his telescope. He had other people there actually doing the observing and making drawings and stuff. Some of the things they saw, like, wow, I've seen that object and it sure doesn't look like that to me. Or the Crab Nebula, if you see his drawing of the Crab Nebula, which is where you get the name from, it's like, it doesn't look at all like that. But in his rather crudely figured and bouncing around and hard to aim, and it went zipping through the field, you know, because they couldn't track things, somebody thought they saw that and drew it, you know, these weird drawings of things. So.
Has there been a study on how much of it was artistic interpretation?
Well, you know, they rebuilt the telescope and brought it up with a new speculum mirror 10 years ago or something or other. So people have been able to look through it. I don't know if you can say you're seeing exactly what somebody saw, you know, to say, kind of like looking at Mars and trying to look for the canals that lots of people have looked through Percival Lowell's telescope at Mars and said, boy, I sure don't see any canals. You know? So, yeah. Yes.
Yeah, so I can relate to this a lot because I do like my astronomy visually and make drawings.
Mm-hmm.
And like some of what you have up there in the lower left corner
Mm-hmm.
is that looks to me like M57 with the
Mm-hmm.
satellite galaxy. And when you do visual work, the sky conditions affect how you perceive.
Yep.
So there was one time when I looked at it through my telescope and it looked like that, where you don't have the spiral arms, you have a ring.
Mm-hmm.
Herschel had seen that effect also. And it's not that that's what it really is, but it is with the sky conditions and how you're perceiving it with your eye, it can take on that shape. And then if you keep viewing it over time, you can begin to get like the spiral pattern start to appear and that kind of thing. But it varies from night to night. So that is also an effect, as well as how individuals will perceive and represent things.
And we don't know how much somebody was drawing at the telescope or remembering it and drawing
Correct.
it the next day or something.
So
too.
it's not
So,
like
yeah.
photography where it's, you know, it's objective. This is a bit subjective on your observing skills, artistic skills, and sky conditions.
Yeah, I didn't pause at that where I was showing the web guide and the picture of one of the pages of the table. trying to think what's on the table. It's Coma Berenices and M65, the Black Eye Galaxy. The description of it, it's not like a galaxy at all. He describes it as a ring, I think. So, and he sees the stars, and it's made of stars.
Mm-hmm.
I see two central stars, and it's like, wow, this isn't how I would describe that galaxy anytime that I've ever seen it. But yeah, it's up to human perception. Anyway, I'm almost through here. I just wanted to kind of close on the personal footnote that one of the things I really enjoy two of the things I really enjoy out of these books, first off, are the illustrations. I love a lot of the Victorian illustrations, but also the writing style is often very evocative and very romantic, and would be hard to match in today's creations, people writing about things. But I find it very enjoyable, and I think this is the last thing I put up here. So this is out of this book. The translation from the French I don't think is that great, but Guillemin says, our object will have been sufficiently gained if in exciting curiosity we have succeeded in giving the desire to study a science so capable of elevating the mind and of affording it the purest and noblest enjoyments. So, I mean, who talks about astronomy like that anymore? But it's still, that should apply now. Anyway, so that's everything I put together. So I'd be happy to have more discussion about it. Tony,
Those scopes from, I had just a couple examples from the 1800s. What would, people could afford fairly good-sized ones. Would they go like to a machine shop with plans of what they wanted?
It depends on where you lived, I think, a lot. So there were people who were making the optics.
Right.
Like Clark and Sons, like Brashear. There were a number of makers in London and Paris who were making the optics for telescopes and would either just sell the optics for you to mount or would sell the whole big telescopes. But then you get all the way down to people making things on their own, especially the reflectors. This is before pre-Victorian era, but you had the Herschels. That was one of the things that William Herschel spent half of his time doing, was making his own telescopes and remaking his own telescopes and trying to figure out how to make a new telescope just so he'd have a telescope. It wasn't that he really liked telescope making. It's just because you need one, and you can't get one anywhere. So, so there are names you see around now, and you would know from this era of telescope making, especially in the refractors, that backing through everything, that reflector, there's the thing with, there's M64 up there. That's what I was saying. I was going to go back to this reflector. That's a Brashear. And come on. Come on, one more. You can do it. There we go. So that was a father and son, really well-known firm for telescope making. Rick?
One other thing that hasn't changed at all since then, and you alluded to it a little bit, was the presence of just flat-out astronomical sensationalism. And it goes way beyond, Percy Lowell and the Canals of Mars stuff. Your friend Camille Flammarion, sort of the Neil deGrasse Tyson of his day, when Halley's Comet came past in 1910, he got his name in the paper and lots of press by announcing that since spectral studies had shown cyanogen gas in the tail of the comet, Earth was going to pass through the tail of Halley's Comet. The cyanogen gas was going to displace Earth's atmosphere, and we were all going to die, which, as you all know, we did. Which is why Douglas are here.
We're still working at it.
And all I can say is, I truly, truly, truly hope his girlfriend was not that gullible.
So is that the
It's
first
always been
comet
that, so I
cult?
guess it always will.
Yeah.
the first comic cult
I
then?
don't know
back
if
then?
anybody actually drank Kool-Aid for it or whatever.
Oh, was that the first comic cult? You know, where the spaceship was following the comet to pick us all up?
Yeah, that's,
That was just
that's
the poison
probably what
comet.
happened.
Well, who is that in back there? It's so dim.
Joe.
Oh, it's Joe in back, okay.
Hey, Drew.
I can see your glasses.
Yeah, I don't.
No, that's okay.
I'll take them off so you can recognize me. But anyway, a little bit of a tangent though is that you could have almost done a part 3 to your lecture here, which would have been also on science fiction.
Oh, yeah.
Which arose in the Victorian era with H.G. Wells and
Oh, yeah.
Jules Verne and everybody from the Earth to the Moon and, you know.
Back
War
when
of
it was
the
really
Worlds.
science fiction and it was really based on, you know, this could happen tomorrow, things, you know. Yeah, it wasn't fantasy. Yeah, that was very true. Very true. And again, that was very popular in that era, right? So Steve again, back there?
Did you come across any books that you would classify as like DIY or how-to books?
You know, not that are quite like the amateur telescope making series. There's stuff about starfinders and things like that. But I've yet to find a book that was really like on telescope making. That's you get up to the 20s, and that's really easy to do. You know, into the 20th century, in the 1920s, that's easy to do. I don't have anything from the 1800s though.
Just follow up on the opera classes. Was there a discussion about angular width of the optics and
You know,
fine power and all
if you had never seen a pair of binoculars with a 6-degree field or something, you didn't know that would be nice. But actually, so opera glass is a kind of an unfair term from our perspective. We're picturing the little folding things from China that don't even have acromats in them and stuff. So binoculars through the 1800s didn't have erecting prisms in them. Usually they had an erecting lens set in them. And so they were longer, and even opera glasses were like that. And so you could get relatively well-made ones. But yeah, even that book, it's interesting to read what he says about getting a good pair rather than, and he talks about, you know, when you look through them, you see 2 images or is it 1 circle and stuff like that. And so he goes into being picky about using a better one than a lesser one. But on the other hand, he's a real encouraging writer, so he's like, if all you got is the cheap ones, use the cheap ones, you know. But if you're going to go out and buy one, look for one that is like this, this, and this. And he does talk about the lens size, but I think that author probably would have been floored to see binoculars with a 50 millimeter acrobat in front of them. I mean, they make them that big. So, but again, the biggest benefit is he's talking to people who are observing under a 5th magnitude sky, you know, and so the little lens, you are seeing a lot more stars through it and stuff. So, yes?
You know, Drew, you mentioned Yerkes, but right in our backyard, in the Victorian era, we have the 18.5-inch Alvin Clark telescope at Dearborn Observatory in Northwestern. So it was built in 1861 and moved to Northwestern in 1888. So, and you can still look through that on a Friday night if you make a reservation.
Yeah. And I think Webb has references to some observations from that in his guide. He lists the Dearborn telescope. So, yeah. Anything else? No, this is a lot of talk.
Yeah. I would say, too, they did have some really good records of things that they saw that have helped me. Like, I like to observe Mars, and I've observed it for many years now. And I can compare my drawings of certain features and compare them to the drawings that were made back then. And you can see interesting patterns evolve. So, like a feature on Mars called the Solus Lacus, the Lake of the Sun. Truvlo, who you mentioned before, the guy with the moths and all that, he would actually look through his scope too and make drawings that way. So he drew it in 1877, this particular feature, where it was just the center part of that feature that was visible. And then when I look at my drawing from 2003, then that's exactly how that feature appeared then. However, when I looked at it the last time in 2020, it had changed again and had a different type of form. And then I could compare that to how they had seen it in the 1920s and say, now it matches that. So you see with Mars, then it will keep changing, but not changing randomly. And you can only recognize that because you have these wonderful records.
Although I'm sure you've seen that, and I'm not just referring to Lowell and Schiaparelli, but I look at the drawings in these books, and they're all over the place, because I'll look at one from 1850 and I'm like, wow, I recognize features. Somebody's seen the same things, and then I'll look at other ones like, what? I could spend a month trying to figure out what side of Mars they were even looking at to see what they said they saw, and it's part of the peril of drawing things. Is and also I would point out too, by the time you get to books, things have been copied a lot of times. Sometimes this is a drawing of a drawing of a drawing, and you don't know or it's a engraving of a drawing of a drawing, and. In some of the books, when you get to the late 1800s, you get to 1890s or so, you're getting books with photographs in them of astronomical things. But by the time they're reproduced in a book, I'm sure they're not looking as good as they did on a glass plate, when they were originally taken. So. Artie.
Drew, I think that what that remark you made about light pollution, it's hard to imagine what kind of a desert we have at night here. I can remember as a kid in the 50s in the deep south, the starlight was so bright you could read a newspaper. It was just, the whole sky was just ablaze.
Yeah.
It's difficult to describe it to people today when you can only see a handful of stars.
Now, if you read something that was written in Paris or in London in 1850, they mainly complain about the smoky soot that's in the sky, and the haze just from that hangs over the city from all the coal fires going and things. So if you were in the cities, the sky might have been less than ideal, but you didn't have to go that far out to get away from that and be under, that kind of a more natural sky. And yes, it's something we have definitely lost, unfortunately.
Drew, I was just thinking about, during the Victorian age, it seemed like they were concentrating more on at least trying to figure out what was going on instead of the earlier century where it's, let's find the next comet, let's find the next planet.
Yeah.
It seemed like it was more science.
I think it has to do because...
everything was found?
Well, the science got more established as a trade. So there you have scientific journals that are out there, and then again you have the universities really supporting astronomy, whereas even in the 1700s it wasn't that common. So in the 1700s it was a hobby, and that's when the Messier and the big comet craze was and stuff. Because it was
Lord Rosse had a big telescope because he was Lord Rosse.
Yeah, well, he wanted to have a bigger one than anybody else, and he built it in the cloudiest spot pretty much on the planet Earth.
Once you stop viewing comets as messages from God, they kind of lose some of their sheen.
Yeah, well, that's the trouble with the stupid Age of Enlightenment. That's one thing that I can mention as a side note. I don't know if it crossed anybody's mind to think about it. The religious references in these books, they're not uncommon, but what I've found interesting in reading through quite a few books is some of them always have to go back to the heavens declaring the glory of God or His creation or this and that. But other ones just don't touch on that one word at all. It's just science, and it's just nature and the way it is and stuff. So there's a lot of variation there. Actually, I've got several astronomy books that were published by religious tract societies. So because the heavens do declare the glory of God. So and they're good, star finders and stuff like that. But there's definitely a lot of variation in whether that makes any difference at all, as things being at all supernatural or mystical or whatever, or just being just plain science and cool how it is. So, probably a lot like you'd find today too. Anyway, we should turn the lights back on, but Chris has the last
One last
question.
I don't think we know.
So this was, especially back in the day, it was more of a rich man's game, right? To build a telescope, have a full-blown observatory, whatever. And the condition of the books, I would say, that you have are also used to be a rich man's hobby.
No,
to
a
collect
lot of
books.
these books were, the Octavo cut books were not that expensive. And they're written for, again, the opera glass guy, this other book that was sitting with it there is Astronomy with the Naked Eye. So, and a lot of them are really aimed at popularizing it. And an Octavo hardcover book wasn't that expensive, you know, weekly wage-wise. To get a book for 25 cents, that was a couple of loaves of bread, I'm sure, but it's probably several loaves of bread, but not unaffordable for the average person by any means.
Well, I guess I was kind of or suggesting that the condition of your books, they look obviously really well kept. That
Oh, well, that's
the only way it
good.
would
I try
stay
not to
well
buy
kept
ones
is-
that are falling apart. It's really easy to find a lot of books that are falling apart.
Yeah.
So
Yeah.
I've repaired a number of them, but yeah, that's kind of my starting point. So I want them to be pretty. And I want to be able to actually read them. Even the ones from the 1700s, I want to be able to open up and read and not have it, the paper flaking off and falling apart and stuff. So anyway, we should turn back up. It's past my time here. So. Anyway, thanks, everybody.